Hello. Yeah, this is visible now. So we were doing this question. Here, this one was your slot welding. Attention number of this paper is published or consists of a channel ISMC 300. Designer fillet weld connection of the channel to a 10 mm cassette. Yeah. Okay. So yeah, this was simply a normal general fillet weld connection. Fillet weld was what? Overlap. This is the overlap. This is the gusset plate. Blue, and the pink one is your channel section. So what happened was that these two are overlapped. So overlap, when we are connecting by welded connection, when a welded connection is done on the overlapped plates, what happens? That is your fillet weld. Okay, so here in the question it was provided what the thickness of the gusset plate was given to us, overlap was given to us, thickness of the weld was 7.6 mm, page number SP16. Okay, for this now, see one thing, for this particular problem, since here this channel section is used now ISMC 300, so for this particular ISMC 300 what you will need is what, your steel table. Okay, the steel table book also you will require there, or I think IS code also you will get, but mainly in the steel book you will get what, for this ISMC 300 all the properties of these ISMC 300 you will get in the steel code book. Okay, so like here you can see in the question which is solved, here you will see page number 44, page number page number 44 SP16 and page number 78 class number 10.5.2.3, table 21 gives the thickness of the web. Web means what? Suppose this was your channel section, like this, like this, like this, like this, channel section. So this is nothing but your web, known as your web. These are your flanges. Okay, these are your flanges. These are your flanges, web. Okay, this is your web, these are your flanges. So thickness of these web is how much? 7.6. From your steel table book you get the properties, these properties. Now I in the last class we have discussed how to find out the minimum and the maximum size of the well, since we since obviously this is, I told you, this is like throat thickness, like normal fillet weld connection. So what will happen, you have to find out the throat thickness, you have to find out the design stress, design strength, easily you can find out. So for design throat thickness you will need what, 0.7 S, right? So what is your S? Your S is nothing but the size of the well, but here in the question your size, nowhere it is mentioned your size of the well. So what we'll do, we'll go to the IS code, we'll take the help of the IS code, and there we will get from page number 78 class number 10.5.2.3 the minimum size of the well, which was 3 mm. Already in the last class, physical class, we have discussed like minimum size is got there 3 mm in the table. You will see if your thickness is how much between this much to this much, values were given. Minimum is 3 mm and the maximum size of the well is how much, the this one, 7.6. This one is the web thickness, right? So this is the web thickness, that means this web thickness So that thickness is how much? 7.6 minus always 1.5. You do the thickness minus this 1.5. You will get how much? This much, 6.1. Thickness of the thinner one minus 1.5. You will get your maximum size of the well. Therefore, what we are going to consider? We are going to consider somewhere near to this the thickness of the well. That is 6.1. This is, so you can take it to be 6 or 5 also, because since we're designing, right? So after considering between the range we have got how much? 3 to 6.1 Now if we take one of these, that is your, we not one of these, nearer to this maximum size, we are taking 5 right? So for 5 throat thickness is how much? 0.7 s, as we have considered to be 5 So 0.7 is how much? Throat thickness is 3.5 Now, what we can find out the design stress. So that is how much? Fu by root 3 gamma mw, and that is Fu is 410. We're considering Fu 410 grade of steel, and we have root 3 by gamma mw. So root 3 gamma mw, what in this question it is mentioned? Field welding. So from table 5 we can find out the gamma mw, the partial safety factor for this. So that comes out to be this much, 157.8. Now the design strength we can find out. Design strength is design stress into length into true thickness. Length of the weld is not provided here, right? Length of the weld is not provided here. So what we are going to do, like in the previous question in the physical class, we have learned or we have discussed that this length will be per length if it is not mentioned, because we'll do the per length design strength we are going to find out, and then we are going to check whether our effective length is okay or not. That means we will find out how much effective length is required. Okay, this length we'll find out. So per length we have calculated the design strength, this one. So effective length of weld is how much now? Effective length of weld will be how much? Our this one was given to us. The factor force is given to be 800 kilonewton, right? And that was to be divided by your design strength per length. So this much. So we have got our effective length. That means the total length will be 1448.39. So we can consider it to be 1449 Width of the slot weld is how much? 3 into TW. That is 3 into TW is the thickness of the web. This one, thickness of the web we have already calculated. So that is 7.6 thickness of the web. So we have got the width of the slot to be how much? So now one more thing. Here, how will know we have to provide the slot, because see the effective length we have got now 1449. But if you see 350 plus 350, that means the overlap was given to us. This is your gusset plate. This overlap is 350. That means this one. This is the overlap, right? Who is this? Okay, so this is our how much? This overlap. That means this portion. If I mark it now, right, red color. Who is this? This one. This portion is your overlap portion. That means this gusset plate is connected with this channel section, and this much is overlap 350 So this is nothing but your 350 350. So now you see here, and this plate size we already know the length of the ISMC 300. This is ISMC 300. So the length of this is how much? The length of these is 300 mm. So we have here 300 mm, 300 mm, right? So this length, if it is 300 mm, you see one thing, if I tell you now, this one, we have got how much? 1449. That means the total length of the well to be 1449. But if you see here, according to the question, the overlap is restricted to how much? The limited overlap is given to be 350. Here you see in the question, this is how much? The overlap is limited to 350. That means it has to be minimum 350 this overlap. So minimum this 350 overlap is restricted. So obviously this is one of the length of the well, and this is also because you're going to weld here only. Previously, you thought of welding here only, this corner, this corner, this corner. Just forget about these slots. Okay, so when we have in the question the general overlap condition, this was the condition, that is your gusset plate, and above that channel section is to be welded. So earlier we would have decided that this portion is to be welded, this portion is to be welded, and this portion is to be welded. Now the total length of the weld would have been how much? 350 plus 350 plus 300. That means 36, sorry, 1000. And 350, 350, 679. Yeah, 1000. Okay, yeah. So you see here, if I tell you now, this one was how much? 350 plus we are having 350 plus we will have 300. Total length of the well, this is 350 plus 300 plus 350 equal to how much? This is equal to 1000 mm, right? So 1000 mm, huh? When we generally, this in the question it was given, this is to be overlapped. So according to that, when we see, we have found how much is our total length of the well from here, 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 these three corners, these three sides. If we the three sides, if we weld, how much is our total length? Our length is 1000 mm. But you see here, when we have, according to our design, when we have calculated what should be our effective length of the well, what we have got, we have found that it should be 1449, 1449 mm. But according to our overlap, how much we got? 1000 mm. So that means what? For to provide the, to carry this much of load, when you are carrying 800, this 800 kilonewton load, to resist that you will have to have this much strength, and to have this much strength you will have to have minimum 1449 mm length of the weld. But since you don't have this, you have 1000 mm. So what we are going to do, we are going to provide these slots. Okay, so when we'll provide these slots, what will happen? This length is to there only 350, 350. Then this portion you can come like this, like this, like this. All this can be like, suppose I'm showing you this, this, this. These are welded. These are welded. These, like this, like this. It will be welded from all these inside the slots also. So that what we are doing nothing but we are increasing the slot. Okay, so we are increasing the length of the welt by providing the slots here. This is the length of your welt, right? So when now we have to find out how much is our this slot. That means what is the this length for your slots. So simply we cannot provide anything, right? So for that reason, you have to. This is one formula where you have to find out the width of the slot. So what is this width of this slot? That is, you have to find out according to ISO, it is given to be 3 into TW, thickness of the web. And the thickness of the web, you have got it from your SP16 table, page number 44, steel table book. So it is 7.6 mm, your thickness of the web. You see here, this is thickness of the web, 3 into 7.6. Now we have got how much? Only 2.8 mm. That means minimum slot which should be this much. But since we don't want to, since we're designing, it is in our hands that how much we need to provide this slot. So we know that how much, 22.8 mm. We don't want to, if you want you can take this, no problem. But since for our easiness we are taking a whole number which is 30, easy for calculations purpose, or anything but more than this is the minimum. So we have taken our slot to be from the ISO 3 into TW. It should be minimum 3 into TW. So minimum was 222.22.8. So minimum is this. Now we'll provide greater than that, that is the whole number for our easy calculation 30 mm. So you will see here, this is the width of the slot. When we have thought, this is up to you, okay, that is you can provide one slot, you can provide three slots, according to you, according to your design, how much slot you want to provide. So in this particular question we have provided two slots, and the width, that means this width of the slot is how much? This width of the slot is to be 30 mm. Okay, so how we have calculated? We have got it from calculating by 3 into TW, thickness, or using the thickness of the web. Now, once we know this, we have, according to our design, your design for our class solution of this problem, we have taken two slots, 30 mm, 30 mm, right? So now, if this is 30 mm, this is 30 mm, what will happen? This, our entire one is 300. So, you can find out this is how much. Okay. So now the length we have to find. Our problem is to find out the length. So how you will find out these length, this length of the slot? Here you will see this is the, how much is the total length? 2 into this one, 350 plus 300, 2 into 350. This is our 350, right? So this is both the sides, 350, 350. This total length of the well is how much? The length of the well should be this much. This one, 1449. Total length of the well we need to have this much, or you can take, according to your design, you can take it to be 1500 also, no problem, or 1450 you can take it. But because it will become more if you take 1500, like more you will need the welding materials, so you can consider it to be, this is the perfect for your carrying the load of 800 kilonewton. So we have got how much? 1449. You can take it to be 1450 also. Okay, you can take it to be 1450. Now whatever it is, we need the total length of the well to be 1449, right? So we will calculate this in such a way so that our length of the well is 1449. So we have how much? This is 350. So how much is the length? This is over 350. This is over 350. So 2 into 350 plus we have how much? These are the width of the slots, right? Or you can say this is 300. This is a 300 only. This entire will be 300, whether it is this this width plus this, that means entirely totally it is 300 only. So 2 into this 350 both sides plus your this length 300. And now if you see, this is the extra portions, this length, this length, this length, that means this one, right? This 1, 2, 3, and here you have 4. So four this weldings are there, 1, 2, 3, and 4. So if we consider this length of this slot to be x, what will be how many x's are there? 1, 2, 3, 4. So now total you see 2 into 350, which is your 2 into this is 350. So 2 into 350 plus you are having 300 plus 4x plus this is your 300 plus 4x is this one, 2, 3, 4, 4x. So now that is total, that should be equal to 1449. We are collecting, or we are using welding in such a way so that we have the total weld length to be 1449 mm. So when we have got this, okay, my battery is running low. So we have 1449. Okay, so this is the equation. We can form this equation from our uh, diagram. 2 into 350 plus 300 plus 4 into x is equal to, this is the total length of the well. This gives us the total length of the well. This much it should be. So from here we can easily calculate the x, that is the length of the slot. So it comes out to be 112.25 mm. So that can be, we can make it a round number, and we can, since we're designing, we can change the values, but obviously it should be more than this. So somewhat more than this little bit. So 112. So it can be 115 mm. So now total length after providing 115 mm, what is our? See here, 2 into 2 into 350 plus 300 plus 4 into x is how much? X we have considered to be 115, this one. So it is comes out to be now our total length of the, after providing the slots, what is our total length of the well? Our total length of the well is 1460. So minimum was how much? 1449 mm to carry 80 kilonewton of load. But now after providing slots, what we have got? We have got our design length of the well to be 1460, which is safe now. It is safe, less than 1499. So safe. Okay. So safe. Okay. So this was our problem for slot connection. For slot. Okay, slot welding. These are known as a slot welding. When we provide these slots, when our length of the design length of the weld is more than the actual length of the well that can be provided, then we cut these portions and we make slots and then we increase the length of the well. Okay, fine. I think my battery is very low, it will get shut down. So we'll stop here now. Another the next day, next class we'll be taking another one more question on slot. These type of questions, these type of slots differently. Okay, so I'll share again once more the link here now, and then you can give me your attendance. Okay. Right, I'm sharing you the link. Let me download the first one. Your first attendance, first class attendance. Now you can give the attendance, which and the link. I'll be sharing here only. Yeah, I have shared. And some of us were not able to do that. Okay, this is the second link you can give here for the second class. You can give your attendance. Okay, take this link, open the link and give the attendance. I think my laptop is going to switch off now. Okay, so thank you.